Welcome student. Last class we have already studied how to calculate the equivalent resistance if the resistors are connected in series combinations. That is nothing but Rs is equals to R1 plus R2 plus R3 plus R4 plus up to so on. It means the effective resistance of the series combination will be what? The sum of the individual resistances or the resistors which are connected in that combinations. Today we are going to discuss one more very important for the point of examinations, that is nothing but what? The equivalent resistance or the total resistance if the resistors are connected in parallel combinations. I think you have already heard the word called a parallel. I can say that these two are parallel. It means they are never going to be meet at any cost. Parallel means this I can say that these two are parallel. In the same, how these resistors can be connected? That should be in parallel combinations. As I already informed you, normally asking for 3 marks questions. What is the term called parallel combinations? Normally you are going to get minimum effective resistance. I will draw here. R1 and R2 are being connected in parallel combinations between the terminals A and B. What the definition says? What the definition says? So, two or more resistors are said to be connected in parallel combination if one end of each resistors. This will be its one end and this will be its one end. One end of each resistors are need to be connected at one common point. So if we are having like this, so we are having two resistors or three resistors, say R1, R2 and R3. They will have two ends. So I am having two terminals, one is here and one is here. So if I want to connect all these three in parallel means, okay, this end is common here, is connected here, this is also connected here, and this is also connected here, same way. So such combinations are going to be referred as what? Parallel combinations. What it says? Two or more resistors are said to be connected in parallel if one end of each resistor is connected at one common point. What is that common point? Say common point A. Say this is common point B. Common point A and other end of each resistors are connected at another point. Say this is a point A. The terminals of R1, R2 and R3 are connected at one point. Another end, say, so these terminals, R1 terminals, R2 the terminal and R3 they have been connected at point B, same here. So R1, R2, R3. So the common terminals of this are connected at somewhere here, one terminals and other, what it says, and the other end of each resistor is connected at other common point such that PD across each resistor. What is that PD? That is nothing but what? The potential difference. Normally you will have a potential difference V between the terminals AB. That will be V be the V is nothing but what? The potential difference across each resistor should be equal to what? The applied potential difference. Understood now? So two or more resistors are said to be connected in parallel means one of ends should be connected at one common point, other ends are going to be connected at another common point such that the net PD across each resistor should be equal to what? The total potential difference across combination of that resistors. That is going to be referred as the resistors are connected in parallel. So how many resistors are being taken here? I am going to take R1, R2, R3. Let us consider three resistors. What are those three? R1, R2, R3 which are being connected in parallel combinations in this electrical circuit. Same way, R1, R2, R3 will be what? Resistors. I1, I2, I3 will be the amount of current and V is nothing but normally you are going to say that battery to provide the potential difference B and a plug key. So are being connected. Let V be the water, the applied potential difference between the terminals between A and B. The current I, listen here, I is being taken out from the where battery is being split into what? I1, I2, I3. It means I1 flows through R1, I2, R2, I3, R3. If it is 4 resistors are there, okay, I4. Similarly, I can say that IN into R. The number of resistors are connected in parallel means the current flows individually. I will written I1 flows through R1, I2 to R2, I3 to R4. So what will be the total amount of current? What is the total amount of current if I am having here I is equals to what? What is the total amount of current? It should be I1 plus I2 plus I3 plus so on up to how many? IN same way. I1 plus I2 plus I3 plus I4, I5, I6. You can consider the n number of resistors which are connected in that combinations. Automatically, it is the sum of the individual the current. So, being written I is equals to I1 plus I2 plus I3. Because I am having how many resistors here? Only 3. I1 flows through R1, I2 to R2, I3 to R3. Or in general, you can say that R1 draws a current of I1, R2 to I2 in that fashions. So we already studied. So according to Ohm's law, what Ohm's law says? V is equals to IR. The amount of current is directly proportional to its potential difference. So I is equals to V is equals to what? IR. What I required here? I should have a value of what? The amount of current. Therefore I is equals to V divided by R. So what about the amount of current in case of R1 resistor? So V is equals to IR, therefore I is equals to V by R. Therefore I1 is equals to what? I1 is equals to V by R1, I2 is equals to V by R3, I3 is equals to V by R3. Similarly I4 V by R4. Up to n number of us. I can say that IN is equals to V by R. It means the potential difference will be remains the same, whereas the amount of current is going to be varying. But in case of series combinations, current remains same. I will clearly written here. What I will written? Common point PD across each resistor should be equal to what? The applied potential difference across the combinations. So automatically V is equals to IR, therefore I is equals to V by R. V by R, I want to have the value of I1, therefore I1 is equals to what? V by R1. Similarly I2 is equals to V by R2 and V3 is equals to I3 is equals to V by R3. Equation 1. So I is equals to what? V by R1 plus V by R2, V by R3. What is the common among all three? So V will be common. I am taking the V as a common factor. What is remaining? 1 by R1 plus 1 by R2 plus 1 by R3 and so on. I can say that will be the equation 2. If RP, P stands for resistors in parallel. RS means resistors in series combinations. Therefore, RP is equals to what is nothing but will be the effective resistance of R1, R2, R3 connected in which combination? Connected in parallel. In that case, what have been taken? They have been series. So RP will be the effective resistance of R1, R2, R3 which are connected in parallel combinations. Therefore, I is equals to what? V by RP. From 2 and 3, what you are going to get? So LHS are same here, RHS will be same. Therefore, V by RP is equals to V into bracket 1 by R1 plus 1 by R2 plus 1 by R3. So and therefore we get cancels. So what is remaining? 1 by RP is equals to 1 by R1 plus 1 by R2 plus 1 by R3. If n number of resistors are connected. what is coming as? Okay, 1 by Rp. N number of resistors. 1 by R1 plus 1 by R2 and so on up to where? 1 by N. Or summation of, you can say that 1 by R. 1 by Rp is equals to summation of 1 by Rn. Ri, where I stand from 1 to. You are getting my point? So I think here we said that minimum effective resistance. So what is that one? It will be the sum of the individual resistors. It will be its reciprocals. Okay, and finally, please make a note, very important. What will be the equivalent resistances for the resistors which are being connected in combinations? Rs is equals to R1 plus R2 plus R3 R4 R5 up to where? Rn. Rn generally I can say that Rs is equals to summation. Summation means what? The sum. The total sum is equals to what? Ri, where I stands from 1 to n. Similarly, what will be the equivalent resistance for the resistors connected in parallel? 1 by Rp is equals to direct equation. Yes or no? 1 by Rp is equals to what? 1 by R1 plus 1 by R2 plus 1 by R3. If 3 are there, if 4 are there, plus 1 by R4. 5 means 1 by R5. How many resistors? Generally I am speaking. In general I am speaking here. Up to where? N number of resistors. Those can be connected in parallel combinations. Means 1 by Rp is equals to what? Summation of Ri, where I stands from 1 to n. After observing these two, it means either you are going to be connecting the resistors in a series or a parallel combinations. The resistance offered by an electric circuit or the electrical device, it will be more in case of series combinations. Remember things. Normally the devices were not going to supposed to connect in series combinations as because we are going to have the more resistance for the flow of electric current. The equation itself says just will add. Okay, if 3 are there, 1, 2, 3, 4 are will be there, the total resistance will be what? The sum of the resistances of each resistors are connected in series combinations. Suppose I am going to take 3 are there here. Okay, 2 is there, 2 ohm, 4 ohm, 6 ohm. What will be its total effective resistance? R1 plus R2 plus R3. Yes, I told. 2 plus 4. Rs is equals to 2 plus 4 plus 6. What is its total resistance? 12 ohm. It means we are going to get a maximum resistances if the devices are being connected in series combinations. It is not at all acceptable. And one more very important thing is the same amount of current is flowing across the combinations. It cannot be possible to operate all the devices simultaneously. So when comes for here, equivalent resistance when they have been connected in parallel, suppose. Okay, they have been connected. Okay, 1, 2, 3. What will be its total? R1, say R2, so R3. So I will take the same values. 2 ohm, 4 ohm, and we have, what is this one? I will take 6 ohm. What is its effective resistance? Just apply it. 1 by Rp is equals to 1 by R1 means 1 by 2 plus 1 by 4, 1 by 6. What is the LCM? What is the LCM of 2, 4, 6? 2 are, okay, 1, 2, 3. What is the LCM here? 3 into 2, 6, 6 into 2, 12. Therefore, 1 by 4. Multiply by 6 into 3 into 2. 6 plus 3 plus 2. What is coming here? What is the total value? 6 plus 2, 8. 8 divided by 8 plus 3. 11 by 12. Therefore, what is the value of Rp? I'll rewrite here. Just a second. I'm writing these values here. So I will make it here. 1 by Rp is equals to 1 by 2 plus 1 by 4 plus 1 by 6. The LCM will be 12. 12 means into 6 into 3 into 2. 6 plus 3 plus 2. So automatically it is 11 by 8, 11 by 12. Therefore, what is the value of Rp? Rp is equals to 12.11. Somewhere around Rp is equals to approximately 1 point. So it will be 120 divided by 11 means 1. So what is the remaining? Only 1 is remaining. 1 3 1. Somewhere around 1. It means that whenever if you want to connect the resistors, especially in parallel combinations, you are going to get the value. There is nothing but what are the resistors which are connected in the series combinations, sorry, the parallel combinations, the total effective resistance will be the least resistors which are being connected in parallel. You know the values 280, 480, 680. Now calculate what is its effective resistance? It is just 1.1 or 1.2 something. So it means it is the best way to connect all the resistors better in a way parallel combinations. Why? Because you will have the less resistance. I can conclude that. So equivalent or the total effective resistance in a parallel combination will be always less than that of the least resistors that is connected in parallel combinations. Hope that practice all those things. So in the last class, as I already communicated in the group, most of you are not doing your homework. Series combinations have been asked you to make twice practice, but you are not done. So I want to have these, either it may be series combination or parallel combinations. You need to practice twice, and that should be updated in the group only. If you are going to have any doubts, you can ask me. And the next part, applications of the advantages and disadvantages of series and parallel combinations, we will discuss in the next class. Along with that, I am going to take a very important, that is nothing but problems related to the combination of resistors, either it may be in series or in a parallel or series as well as parallel combinations. Okay, hope that you are understanding each and everything. So if you have any doubts, you can personally call me or you can update in the group. Thank you.